Hello everyone, welcome back to HMAT1033. Maybe so far some of you kind of wondering how will I take the radical of the negative number. So far we know that if we take even radical, we can only take radical of a positive number. If we take odd radical, yes, we can take odd radical of positive and negative number. But for even, as I already say, we can only take even radical of positive number. Then how are we going to take even radical of negative number? For example, what if I want to take radical of something like this? A square root of -2. How we gonna do this? What did it give you? We know that if we take square root of +4, it gives you 2. But what if I want to take the square root of -4? What did it give you? In this case, we have to use a different system. You know, the answer is not in the real number system anymore, but the answer would be on another system. We call that system is a complex number system. Okay, so in this video I will be discussing what a complex number is and how we're going to use complex number to write our final answer every time we want to take even root of a negative number. For example, in this case is square root of -2. Okay, so let's start it with our concept today. So I'm gonna put today, I'm gonna put the topic is a complex number. Complex number. Okay. You know, everybody know what's the real number is, right? Oh, you know the whole number. A whole number is it's just natural number, right? And it could be positive or negative, so it could be integer, right? You never learned complex number before, because probably some of you heard a complex number already, but a complex number is pretty hard concept. If you want to go really deep into that, it's a very hard concept. You know, it's just it is a totally different branch in mathematics. All right, so what is complex number? Let's start with our first part of the lecture, the definition. We need to know what complex number is. Definition. Okay. A number, if the number can be written in the form okay, a plus or minus bi, then that number will be called complex number. What is a, what is b, and what is I over here? Of course, we need to understand it. So the a over here, we call that the real part. Okay, and bi over here, okay, we call that imaginary part. Okay, and the I value itself, we call the imaginary unit. Okay, so actually any real number can be written as a complex number. For example, I just want to write a 5. Actually 5 is a real number, right? 5 is a real number, and it actually is a complex number too. Okay, for example, I can give you a complex number like this. A, in this case 2 plus 3i. So this is a complex number. It has the real part and it has the imaginary part. Okay, Or 5 is also a complex number, because 5 can be written as 5 plus 0i. So any real number, any positive or negative real number you learn so far is a complex number. Actually, it's a complex number. Or I can have something like this. So I have negative 3 minus 2i. This is also a complex number. Or some complex number, it doesn't have it doesn't have a real part. For example, 8i. This is also a complex number. It just doesn't have a real part. Okay. Okay. Or any number, let's say any real number, positive or negative real number, could be a complex number. All right. Okay. Now, because complex number is a number, and we know that. We know if we have a number and we have two numbers, we can add or subtract, we can multiply or divide. Okay. Okay. Then maybe in complex number we can also multiply, divide. We can also add or subtract together, right? But before we go through that stuff, I just want you to know this. So I'm gonna put a remark right here because this is very important. Okay. I'm gonna put a remark here. Okay. The imaginary unit over here, the I unit over here, if we go ahead and square it, this is give you -1. Wow, this is very interesting thing, right? If you square it, it gives you -1. Well, I can go through some proof over here if I want it. And actually, if you have time, you can go ahead and look it up. Why I square equal to -1? But I'm not going to go ahead and spend time doing the proof for you why I square equal to -1. Okay, because we just go ahead and take it for granted in this level. You just need to know, okay, I square equal to -1, and if you want to, if you're really curious why I square equal to -1, go ahead and look it up for yourself. Okay, it's on the internet. You know, it's very popular proof. If you, it's pretty easy explanation why I square equal to -1. You can go ahead and find it for yourself. Okay, and this information here, this fact over here is very important. It's going to help us to multiply, dividing, to add or subtract complex number together. Okay. Now on the second part, so after we know what complex number is, okay, we know what complex number is. Let me see. Before we maybe I'm gonna give you another example before we can do some operation on complex number, because we already know I square equal to -1. Or maybe some of you want to ask, okay, so after we know what complex number, how are we gonna take square root or end root of negative number? So let's do example number 2 here. Okay. Let's do example number 2 here. What if I want to take square root? I want to take square root of -2 or -5, for example. Usually, if you don't learn complex number, you're gonna stuck right here, right? You're gonna get stuck here, and you cannot continue with this. Okay, with this problem. But what if you already learn what complex number is, and you know that I square equal to -1. So I can write square root of -5 as square root of -1 times 5, right? And -1 is what? -1 is I, so I can write it as square root of I square times 5. And what is square root of I square times 5? You know, we're going to use the property we learned last time with square root of I square times 5 will be square root of I square times square root of 5, right? And square root of I square, and we already learned the formula last time, right? The index over here, the exponent is the same. So square root of I square actually I square root of 5. So that will be your final answer in this case. Okay. So you see it's how helpful this fact is. You know, it's gonna help you to, you see that it's gonna help you to calculate evaluate the square root or any even root of any negative number. For example, I can do fourth root. I can do fourth root of negative 10. I'm going to do the same way. Maybe so. In this case, you can do like this. So square root, fourth root of negative 10 will be fourth root of negative 1 times 10, right? And this can be split up into fourth root of I squared times 10. But the problem is, you see that 4 is not going to 2, right? So I can before I can do anything, I can go ahead and split it up. So this is 4 root of I squared times 4 root of 10. You know, 4 root of 10 we can do it, but 4 root of I squared 4 root of I squared, remember the index over here is bigger than the exponent, so I just can write the imaginary unit raised to the half, right? Because 2 divided by 4, you simplify it, it gives you half. Okay, so this is give you 4 root of 10. So that will be your final answer. So you see that you can, as long as you learn this fact, you can take any even root, okay, any even root of any negative number, okay, including fraction if you really want to, okay. Now let me give you another one, and in this example, probably that you have to simplify a little bit here. What if I want to take? I want to simplify. Okay. So let me give you that. I'm going to put it over here. Example number 3 here, and I want to simplify square root of negative 48. Okay. So negative 48 is I can write it as I square, right? And 48 is 16 times 3, right? And now I can split it up if you want it, or maybe you can do a mental math over here. You can get right away, but I'm going to go ahead and split it up because just in case some of you have not memorized the formula yet. So I just go ahead and split them up into 3 radicals. So right now we're going to have square root of I squared, which is give you I. Square root of 16 is 4, so you can have 4i times square root of 3. There you go. So you see that after we know a complex number, after we know this fact, we can simplify any even root of any negative number. You know, the answer, you see that the answer is not just a whole number anymore, but the answer is another complex number. You see that? The answer is a complex number because it have I over here. Okay. Okay. All right. Now, after we know how to simplify radical of negative number, we know what the complex number is. So on the second part of our lecture, I want to talk about operation on complex number. Operation on complex number. We mean that how we're gonna add, how we're gonna multiply, how we're gonna subtract complex number together. Okay, let's see how we're gonna do it. Let's see, we can add or subtract first. Okay, let's do add and subtract, then we're gonna do multiply and dividing. Okay, so I'm gonna put over here as part A, which is adding and subtracting. Alright, so the strategy is that you're gonna add if you want to add two complex numbers together, you will have to add the real part together and the imaginary part together. You cannot go ahead and add imaginary part and real part together. Okay, so it's like you combine like term. Okay, so the strategy, the tactics. Okay, the tactic will be I'm going to use the tactic will be add add or subtract real part together. Then add or subtract imaginary part together. You cannot add or subtract the real part and imaginary part together. It is not working. For example, example number 1 over here. All right. Let's see. Okay. Now, what if I have two complex number like this? I have the first complex number is negative 3 plus 4i, right? And I want to add to another complex number, which is 5 minus 3i. Okay, so this is two complex numbers together, right? So we're gonna go ahead and add the real part together, which is negative 2. Okay, we're gonna add negative 2 and 5 together, so which is negative 2 and 5 give you 3, right? And we're gonna add our imaginary part together, 4i plus minus 3i, so which is 4i minus 3i will be 1i. Oh, here you go. That's it, huh? So you see that if you have complex number, add to another complex number, it will give you a complex number. Okay, but for the subtraction, it will be a little bit different. What if I have over here? I have I can have like 3 plus 2i minus 4 plus 8i, for example. Okay, so in order to subtract, we need to get rid of the parentheses, so I have to go ahead and distribute this first. So give you 3 plus 2i minus 4 minus 8i, right? Alright, now we're going to combine them. 3 minus 4 give you negative 1. 2i minus 8i give you negative 6i. Here you go. Okay. Yeah. You cannot go ahead and add 3 to 8i. 3 to 8i. It give you 11i. It's wrong. Okay, so remember, the imaginary part must be go together, and all the real part must go together. Okay, that is adding and and subtracting. How about multiplying? Okay, multiplying and dividing. Okay. Of course, every time we talk about multiply, we gotta use the distributive property. Excuse me, guys. So tactic. Okay. Applying distributive property. Okay. Alright, example number 1. What if I have this? What if I have let's see, I need to find something. Okay, how do I have a complex number, right? And I want to multiply by another complex number like this. Okay, then we just go ahead and apply the distributive property. So we go ahead and void them. So 2 times 7 will be 14i, and 2i minus 10i, which is to give you negative 2 times 5 is 10. I times I is be I square, but I square give you what? I square give you negative 1, so this is to give you 14i minus 10 times negative 1, right? So which is give you 14, give you negative times negative, you be 10 plus 14i, or 14i plus 10 will be the same thing. Okay, so basically you just need to apply distributive property. How about this one? Example 2. Now, what if I have this? I have a complex number like this, 3 plus 2i, and I want to multiply by 4 minus 3i. Okay. Alright, so I'm going to start folding again. So this go to this, give you 12. This to this could be give you negative 9i. This going to give you 8i. And this is going to give you negative 6i squared. So which is give you what? 12 negative I squared equal to negative 1. Negative 1 times negative 6 give you positive 6. So 12 plus 6 is 18 minus I, which is another complex number. So you see that over here. So basically what you have to do is just this to this, this to this, right? This to that, and this to this. Okay. Example number 3. That's multiplication. Now what if I want to do something like this? How about division? Let's talk about division. Maybe division is more important too. It's very important. So how about what I have negative 3? Negative 3 is a real number. It's a negative number. This is also a complex number without a real, without the imaginary part. So you divide it by 5 plus 2i. Okay. All right. So in order to do division here, this is what you have to do. Remember, last time we already talked about a conjugate. So in order to do this, we have to multiply the top. Okay, the tactic will be multiplying the top and bottom by the conjugate of the bottom. Okay. Okay. So what is the conjugate of the bottom? The conjugate of the bottom is 5 minus 2i. This is the conjugate of this. So I'm going to multiply. Okay. I'm going to multiply negative 3, 5 plus 2i by the conjugate of the bottom, which is 5 minus 2i times 5 minus 2i. So I multiply by the conjugate, right? And now you see that on the top, now see that. Okay, so what do we have over here? What we have over here? We have this times this, right? So I can write it as negative 3, 5 minus 2i. You can go ahead and distribute, but I think I'm gonna leave it in factoring form here, just in case that I probably can show the bottom with negative 3. So try not to don't distribute it, okay? And if you recognize over here 5 plus 2i, 5 minus 2i, which is this difference of square here, so give you a square minus b square. It will be a square minus 2i square, right? This is a difference of square. A square minus a square minus b square, right? Remember that one, the formula. Hopefully you guys still remember that formula. A square minus b square is a minus b times a plus b. So I'm going to use that formula right over here. Okay, and now what we have over here, we have negative 3, 5 minus 2i, And at the bottom, what we have? At the bottom we have 25, right? So negative 2 squared give you 4, and time I squared, right? Okay, I'm going to do step by step, and I squared give you negative 1, which is negative 3, 5 minus 2i over what? Over 25, I squared equal to negative 1 times negative 4 give you positive 4, which is the bottom I will have 29. Oh, unluckily we cannot simplify 3 and 29, so I'm gonna just leave it there as the final answer. But if the question, okay, if the question asks you to express your final answer in the complex form, so you're not gonna leave it like this, okay? If the question is just simplified, then you can leave it like that. But if the question is, okay, go ahead and write this number as a complex number, so you gotta multiply the number, which is give you negative 15 plus 6i over 29. Then go ahead and split them up, so we have negative 15 over 29 plus 6 over 29. Here you go. This is a complex number. You see, this is a real part over here. This is a real part over here. It's just a fraction, and imaginary part it has a fraction. A over here. This is b right here. A b right here. Okay. So if the question asks you to write it as a complex number, this is what you have to do. Okay. Now in the next example. Example number 4. I have something like this. It's kind of pretty interesting also. Yeah, what if I have 5 plus 3i, and the bottom I have 4i. Okay. Alright, so it's the same thing. We're gonna multiply the top and the bottom. We're gonna multiply the top and the bottom by the conjugate. So you're gonna multiply the top and the bottom by the conjugate of the bottom. The conjugate of the bottom will be, if this is a plus, so the conjugate will be minus. So we'll be multiply the top and the bottom by minus 4i. Okay, by minus 4i. Okay. Alright. So I multiply by the conjugate. Now I just go ahead and FOIL them. Okay, I think we should go ahead and FOIL it, because in this case, you see that in this case this is negative 4i. So maybe I think you should go ahead and FOIL it, because you FOIL it, you can write it as the complex number as the final solution. Okay. So let me do another step. I can reorder them. Okay. Now 4i times negative 4i, which is negative 16i squared. Alright. Now you see that I can simplify this. 4 and 16, which is give you 4, and I squared simplify, which is give you, oh no, if I do like that, it will give you back. So in this case, I just go ahead, let me see. I can go ahead and change I squared. Yeah, I'm going to change I squared into negative 1. So if I squared equal negative 1, negative 1 times negative 6 will give you 16. And now I simplify 4 over 16, which is give you 4 over 16, which is give you 4. Okay. Then I'm going to distribute the negative I in, so give you negative 5i, and negative I times 3i give you 3, give you minus 3i squared over 4. And I squared equal to what? I squared equal to negative 1, so I can write as I squared. You see the fact that I squared equal to negative 1 is so important. You see, every time you see I squared, you just go ahead and convert it into negative 1 plus 3, right? Over 4. And now we're going to reorder them. Okay, Okay, reorder them. Then we're gonna go ahead and split it up so that we can get a complex form. There you go. There you go. So this is your real part right here, and then this is the imaginary part. So this is your A, and this is your B is -5/4. Okay. Good. Example 5. Actually, all the problem is kind of, it kind of same step. You know what I mean? How about this one over here? I have 4 plus 3i, and over here I have 3 minus 4i. Okay, it's not a big deal. So again, we're gonna multiply the top and the bottom by the conjugate. So the conjugate will be what? The conjugate will be, let me use the conjugate on it has to be 3 plus 4i. So 3 plus 4i, 3 plus 4i. Okay, and now we're gonna go ahead and just void them. Okay, just void them. Okay, so void them. So we have what? I mean, we have 4 plus 3i times 3 plus 4i. I just want to rewrite it in one fraction only. It's easier for you to see. And now I'm going to void them. So just give you 12, 16i, and 9i, and 12i squared, over what? Over 9 plus 12i minus 12i. Oh, you can apply a different square right here. It's faster. So it could be a minus b, a plus b could be a squared minus b squared. Okay. Now at the top, what we have? We have 12 plus 25i, right? And I squared equals -1. So if you -12 here, I cancel them. And the bottom, what we have? We have 9, right? Minus 16i squared, right? And I squared what? I squared equal to -1 again. So give you 9, and -1 becomes 16. So give you 25i over 25, which is only I left. Oh, well, that's great. It's still imaginary number. It's still complex number. It's just the A is 0. You want to write this, so actually you can write like this: 0 plus 1i. 1i is I. So that's a complex number form. Okay. Good. All right. So after we know what complex number, actually you can go ahead and add or subtract radical. Because add and subtract, multiply radical, divide the radical with negative radicand. You can do that easily. You just basically when you simplify the final answer, which is using the I squared equal -1. Okay. Now I'm going to give you a very interesting problem. And again, we're going to use the fact I squared equals -1 to do that. Example number 6. Okay. What if I want to simplify this? What if I want to simplify I-86? I-86. I raised to the 86. Okay, this problem I'm gonna put it on the test, okay? Because I just want to make sure that you guys really understand how we use the I squared equals -1. So we know the fact. We know the fact that I squared equal to -1. That's this fact. And how we're gonna use this to evaluate this, to simplify this. Okay, it's pretty easy. Okay. Okay. So I don't know. I cannot change it to somehow I cannot change it to white color. And now it's working now. Okay, we know that I squared equals -1. And how we calculate I raised to 86? You know, nobody gonna have to split it up into like I square until you add them up and it'll give you I-86, right? Nobody do that. Actually, you can, but I mean it's take forever. So this is the strategy. We know that 2, we know that 2 is going to 2 going to 86. So I can write I raised to the 86 as I square raised to 2 or something, right? 86 divided by 2 give you what? Give you 43, right? Right? Yeah, give you all 43, and 43 is an odd number. 43 is an odd number, and we know that I square equals -1, so which is -1 raised to the odd number 43, right? Exponent 43. Okay, exponent. Okay, so, and if it is an odd number, so just think about it. You have -1 raised to the third power, right? If you raise to the third power, give you -1 because third power is odd. So 43 is odd, so -1 raised to 43rd power, which is give you -1. Oh my God, it's so fast. There you go. So there's some step you need to show me. You don't have to show me a lot of steps if you're really good at it, but this is enough for me to understand. So on the test, you have to show me at least few steps. 4 or 5 steps. Okay. How about this one right here? Let me give you something more interesting. What do I want to simplify? Simplify. I-109. Oh, how will this? We know that I-109 is we know that 2 is not going to 109, but we know 2 here is going to 108, so I can split them into I-108 times I, right? And 108 is 2 going to 108, so I can write this as I square raised to what? 108 could be 54, right? Alright, times I. And now what? And now I square equals -1. -1 raised to the 54. 54 is even. So think about -1 raised to the second power, which is give you 1. So -1 raised to the 54 power, which is give you 1. 1 times I is I. Here you go. This is what you have to show me on the step. Okay, split it up like this: 4, 5. 1, 2, 3, 4, 5 steps. Okay. Good. Complex number is pretty easy. Okay. Let me see. We can go back and use the complex number to simplify the one of the radical we learned last time. How about this right here? Example number 8 over here, and this should be the one of this is maybe the last example I give you in this lecture. What if I have 3 minus square root of -12, right? See, that's the square root of negative number, which is related to the I complex number, right? Give you a square root of -27. Okay. So how we gonna multiply this? That's okay. We just go ahead and multiply using the distributive property as you give you 15 plus 3 square root of -27 plus 5 square root of -12 minus time plus give you minus square root of positive, right? We're gonna -12. I'm gonna rewrite it time -27, pretty big number. Alright, so we can do like this. So 3, so I can split it up, which is -9 times 3, right? And this is I can split it up into -4 times 3. Oh, this is give you negative become positive, and 12 will be 4 times 3, and 27 will be 9 times 3. Alright, so which is give you 15 square root, so give you 3 here, and -1 I can write it as I square times 9 times 3. Same thing over here, I can write it as the -4 will be I square times 4 times 3, because I square and -1, so I can change the negative sign over here to I square. Now I can write this as 4 times 9, 3 times 3, there's another 9. Okay, 3 times 3 is another 9. Now, And we know that I square square root of I square is I, so we come 15 square root of 9 is 3, so 3 times 3 is 9i square root of 3 plus, same thing over here, square root 4, 2 times 5 is 10i square root of 3. And what is this? Square root of this, so I can change the square root of 81, which is 9 times 2 is 18. Alright. Right? I'm gonna do a quick write over there, but I can show you really quick why. So over here, actually this is square root of 4 times 81, right? And square root of 4 is 2, square root of 81 is 9, 9 times 2, 80. Here you go. Okay. And now what we have 9i plus 10i. I can combine right term because it's the same radical and the same radical. So we give you 15, give you 9i plus 10i is 19i square root of 3 minus 18, and 15 minus 18, which is give you what? Give you negative 3 plus 19i square root of 3 as the final answer. You cannot do anything else. So, you know, if this one is 18, maybe we can go ahead and factor negative 3 out, but this is 19. 3 is not going to 19, so I'm going to just leave it like this as the final answer. Okay. Okay, so I think that's all for the complex number. And now, from now on, if you see something with a radical of negative number, you must go ahead and change it into complex number. Okay, we're not going to leave it radical. For example, you cannot go ahead and leave it radical negative 2 as the final answer anymore, but you got to change it into something related to I. Okay, so that's it for the lecture video today. I'm going to stop right here, and I'll be seeing you next time. Bye-bye.